Hello, one more time. This is our third and final video for section 3.5 or 3-5. This is 3-5C. We are on page 171 of your textbook, and we're going to look at evaluating functions. We're going to look at two different examples for evaluating functions. The first one's pretty straightforward. It's the kind of evaluating that you've been doing all semester. The second one is peculiar to functions themselves, and it's a little weird, a little odd, but we'll take a look at it, and I think you'll get the idea once you see a good example. Let's begin with example one. This is the more straightforward type of evaluating functions. And in this question, we are given the function f of x is equal to 3x to the second power plus 2x minus 1. And we're asked what is f of 2. All right. So what we've done is we've gone from f of x, that's just our input variable in general. There we go. And now we're going to replace that x with a 2. And since they've replaced the x in the original notation with a 2, we're going to replace the x everywhere else with a 2 as well. So we're going to get f of 2 is equal to 3 times 2 to the second power plus 2 times 2 minus 1. Notice my careful use of parentheses, same as they did just over to the left. This is really especially useful when you're substituting in negative numbers, and you will come across negative numbers in your group work and in other work. So please be careful with your substitution. We can go through and do the math. F of 2 equals, we're going to end up with 2 to the second power is 4 times 3 is 12. We're going to have 2 times 2 is 4. And then we still have the minus 1 over here. So we end up with f of 2 is equal to 15. 12 plus 4 is 16, minus 1 is 15. And notice how useful this notation is. We know what our function was, f, we know what our input was, 2, and we know what our output was, 15. That's a lot of information that's captured in a very tiny little bit of notation. Matter of fact, if we wanted to graph that point, we would immediately know that its coordinates are 215. So we can read points really quickly and easily from this notation as well. This is something that I didn't get a chance to mention in the earlier videos, but I do want to point out that there is a reason for this notation. It is really dense in the amount of information that it carries and transmits to us. Tells us a lot of stuff and does it in a very small set of symbols. All right, so just asked for f of a number. Pretty simple and straightforward to evaluate that. Substitute for the letter, go through and use your order of operations to get a number, and we're done. I'd like to see you write your final answer not just as a number, but as f of the input is equal to the output, just as I've done here. So f of 2 is equal to 15. In example 2, this is the one that's a little bit different, a little weird. It's not too bad though. Don't let me scare you off. All right, here we're given f of x is equal to 2x plus 5. So let me write that down here. F of x is equal to 2x plus 5. And we're also told that f of x equals 11. And then we're asked, what does x equal if that's true? So we also have f of x is equal to 11. So what we have here are f of x being equal to two different things. And what that implies, if you remember back to the substitution work that we did in section 2-4, is that those two things must be equal to each other. In other words, I can replace f of x in the first equation with 11, and we have 11 equals 2x plus 5. Or I could have replaced f of x in the second equation with 2x plus 5, and we get 11. Either way works, it doesn't make any difference. Let me work with the second one because it's generally a little bit nicer to have the variable on the left. So to solve this for x, we're going to subtract 5 from both sides. 2x is equal to 6. We're going to divide both sides by 2, and x equals 3. So what that tells me is that f of 3 is equal to 11 if we go back to our function notation. And we can double check that, right? Oops. We can figure out what f of 3 is if we want to check ourselves. So f of 3 is equal to 2 times 3 plus 5. F of 3 is equal to 6 plus 5. F of 3 is equal to 11. right? But we didn't know that it was 3 as an input first, so we had to use that 11 as the output and then solve to get there. And that's what makes these questions a little bit more interesting. A little bit of a hint, when you get to your group work on the next page, numbers 1 and 3 will work like example 1. Let me write that for you. All right. Numbers 1 and 3 will work like example 1. Numbers 2 and 4 will look like example 2. And one of the things you should do is pay attention to how those questions are worded to see if you can understand how to recognize yourself which one looks like example 1 and which ones look like example 2, so that if you see those later on a quiz or a test, you know how to approach them. All right? Thank you.